You're one of the SAP customers or partners. There's a gathering with the SAP team in front of the Pylog booth. Please join us there. It's my great pleasure now to welcome our closing keynote. I want to introduce you to a man called Douglas Chan. Douglas is the Chief Operating Officer of an incredibly interesting business called Climeworks. And Douglas started life as a mechanical engineer in the maintenance and reliability group at ExxonMobil. He continued his career at Tesla, where he reported directly to Elon Musk for a period of time. He built, operated, and maintained manufacturing lines. He now works at Climeworks. It's headquartered in Zurich. Interestingly, he lives in Austin, Texas, and he works in Reykjavik, so go figure on that. They're a company that's operating plants in Iceland, and they're pioneering green innovation where they direct air capture plants that suck CO2 out the atmosphere in Iceland. It's amazing. I mean, I could hardly say it, but you can watch the video in a moment and fully understand it, and then Doug's going to explain it to you fully. And he's going to share some lessons today from this first-of-a-kind plant, and a cracking way for us to finish mainstream, because it really is world-first innovation, and I'm really excited to hear him speak because he's also a wonderful storyteller. So to see what that looks like, and to join me in welcoming Doug, we're going to watch a little bit of a video, and then Doug's going to come up to the stage. So I give you Doug Chan. Cool.
Firstly, I'd like to start by thanking all of you. This is the first time I've been at one of these mainstream events, and honestly, the passion for maintenance and reliability, I haven't felt that in a long, long time. So to be surrounded by all of you who are either operators, owners, solutions providers, it's a huge community that I'm really thrilled to be part of. Pro Reliability Solutions, they've been helping us along with our maintenance journey to build a maintenance excellence strategy up in Iceland. I wouldn't be here or have this opportunity without them. So thank you, Mark. Thank you, Gary. And thank you to all of you. So for making it this far in the day, I have the unenviable task of standing between you and drinks. So I'll get on with it. So my entire life, my career, has been spent in the design, build, operate, and maintain life cycle. And I won't have 40 years of experience, 40 years and 40 lessons like Gary's. Well, I think I've got 40 lessons. I've probably got 400 lessons and 400 scars as well from these lessons. But I don't have 40 years of experience, but I'd like to share at least where I've come from along in my journey in this life cycle. And like Steve mentioned, I did start my life in this maintenance and reliability group at Exxon, not really knowing what this all was. And I spent a lot of time doing rotating equipment, turbines, compressors, generators, all offshore oil rigs in the Bass Strait of Australia. Everything from aging assets to some of the newer assets. And for me, it was really interesting, but I didn't enjoy the cushy ivory tower on South Bank, sipping lattes, drinking scones, and really enjoyed being out there in the field. So what I did, Solar Turbines was one of our key vendors, turbines, compressors, generators. So I said, hey, I'm going to hang up the slacks and shirts, put on a set of overalls, and become a field technician for solar turbines. And that, for me, was probably the best decision I've ever made in my life. Those 4 years I spent in the field, the amount of experience that you learn working 24/7, well, 12 hours a day, you get rung up in the middle of the night when the platform's gone dark and you have to get up and figure out why the turbines sent the whole platform black. Those are experiences that I'll take with me forever and have taken with me through my journey in my career as well. After spending that time in the field, burning my fingers, Tesla came along and you're probably like, what's electrification and automotive got to do with gas turbines and compressors? Absolutely nothing. So Australia was going through an automotive recession. Tesla was trying to scale up. They went to Australia to try and pick up automotive engineers. And they saw in my title, equipment engineer, rotating equipment engineer. And they're like, we need manufacturing equipment engineers, so you probably do something similar. That was the start. Thank God for stupid recruiters. Let's bless the recruiters, otherwise I wouldn't have actually had that opportunity. But that was the start of my journey at Tesla, where I was fortunate enough to then start to see the entire cycle and piecing together the design piece as well, where I was brought in as a manufacturing engineer to do the Model 3 retrofits for paint, where in California, where we were looking to scale up production from the luxury Model S and X's through to the high volume Model 3s that are all over the world today. And in that time, I was fortunate or unfortunate enough to have to work directly in Model 3 production hell. So some of you may have heard about that in the news. And unfortunately, that hell was the paint shop. So I saw a few people in automotive, maybe a show of hands of those who are in automotive. Yep, so yeah, we cause a lot of your headaches, unfortunately. We're the ugly sister in the middle. So we were the bottleneck, and he fired my boss and said, hey, you're all reporting to me. I split day and night shift with the production manager. He ran the days, I ran the nights, fixed everything that he broke during the day or that we broke together, and also had to look after both what the manufacturing team had installed as well as the existing equipment. And during that time, there were no roles and responsibilities. We were all just trying to do our best and figure out what was wrong. Coming out of that, I was actually then called by the exterior design director at the time, and he's like, look, I've got an opportunity for you. Elon said he wants you to be the senior maintenance manager. And he's like, you can think about it until lunch. You can call me and say yes. And I was like, well, I guess I'll think about it till lunch and call him and say yes. And for me, that was, maybe it was the foresight that he saw, but I then had to be fully embedded in the maintenance organization and stand up for the next year the maintenance systems and processes within Tesla to get Model 3 not just ramped, but operating and machinery operating reliably. With those learnings then, I went back into the manufacturing engineering space and really got to grow through the purple patch of Tesla as well. I mean, there's not many companies where in 4 years you get to build and ramp 4 lines. So I went to China, spent 9 months doing the quickest ever build of an automotive factory there. Then I did Berlin. That got interrupted by COVID, and I'll share some of those lessons as we go today. Then I did Texas. Then I came back to California again, and then ran production facilities and the battery facilities there. So throughout that time, I was able to kind of really see the entire circle of design, build, operate, and maintain. And that really gave me an appreciation of how all of these things have to work together. And now I've brought that final experience to Climeworks, where Climeworks is building these, for lack of a better word, massive vacuum cleaners that are sucking up CO2 from the air and then storing that CO2 underground. Now, I'll spend a little bit of time explaining what Climeworks is, just so that you can kind of piece together the maintenance and reliability story with this nascent, almost science fiction-esque technology. So direct air capture is about carbon removal. And I'm not going to stand up here and preach to you about climate science, eating vegan. I mean, I love a good steak, medium rare, Scotch favourite. But it is an important problem that we have to solve with urgency. And I'll start with some of the facts about why we're doing what we are doing. So what you see in front of you here is a graph of CO2 emissions since the Industrial Revolution. So you've got the mid-1800s on the left, all the way until present day today. And each of the colour bands represent either an emission or absorption of CO2. So if we start above the x-axis, what you see is, no surprises, the grey bar, fossil emissions have been growing. Where has all of that gone? Where has that 40 billion tonnes of CO2 that we emit every year, where does it go? It doesn't go into outer space. It actually, a quarter of it, the dark blue, gets absorbed by the ocean. The ocean does a great job for us. The land also does a great job as well. So half of it is actually absorbed by our own Earth. So Mother Nature is doing a huge job to try and protect itself from this global warming effect. The last half of that CO2 we emit contributes to that pale blue, to that atmospheric growth. And for me, the simplest way I think about it, it's like you're shoving feathers into your blanket. So you're just shoving more and more and more and more feathers. It's keeping the Earth warmer and warmer and warmer. That's what's leading to now this global warming effect that we all like to call it. And we're trying to keep the whole global warming below 1.5 degrees before what all the climate scientists tell us bad things are going to happen. So maybe the first interactive one is show of hands. Actually, everyone put their hand up, because what I'd like to understand, we are warmer than where we were at pre-industrial times. So I think everyone would agree that we're more than 0 degrees warmer than we were at the Industrial Revolution. Are we half a degree? So last year, if we look at 2024, we're still in 2024, last year, are we half a degree warmer? Are we more than 1 degree warmer? Some hands going down. Are we more than 1.5 degrees warmer? Are we more than 2 degrees warmer? Are we more than 2.5? All right, so all the hands have come down. We're actually, in 2024, we were 1.6 degrees Celsius warmer than pre-industrial times. So this 1.5 degree kind of alarm bell that the Paris Agreement said, hey guys, bad things are going to start happening. This is knocking on our door today. And that's why I've been so passionate about solving this problem. And carbon removals are one aspect of solving the problem. So let me paint this in the bigger picture of how else do we solve this problem. Now the last graph was from 1850 to today, whereas this one looks at today, we'll call it 2010, but today and moving ahead, and the path of our CO2 emissions. The red bar, the current climate policies, if we don't do anything, will continue to emit our 40 billion tonnes of CO2 a year. If we want to stay below that 1.5 degrees, what we need to do with our CO2 emissions, our net CO2 emissions, is to follow that white line. And interestingly, what you'll see with that white line is that it crosses the x-axis, it goes to 0 in 2050. So we actually have to be at net zero by 2050. There are two critical pieces of the puzzle to get to net zero. There's the pale blue section, the reduce as much as possible. And this is the avoidance that many people are familiar with. That's the conversion of coal to solar or wind. That's the installation of point source carbon capture. I had a great conversation with Richard from Heidelberg Materials. They're looking at building the world's first green cement plant where they're going to be capturing the CO2 emissions from the plant and storing it. So that's the entire avoidance piece. But what you'll see is that pale blue bar only gets us so far. It doesn't take the feathers out of the blanket that we've already put in there. And that's the negative emissions piece. And the negative emission technology, which is what Climeworks has been working since 2009 to invent, deploy, and scale up. That's actually so people are like, hey, this is great. You feel great about trying to reduce climate change. How do you actually make money? So as we remove the CO2 from the atmosphere and store it underground permanently, we account for those as CDR credits, carbon removal credits or carbon removal certificates, and we sell those to our customers who have these net zero targets. So the Microsofts, the BCGs, the JP Morgans. We've been building a voluntary customer base who have their internal sustainability targets. A conversation this morning about energy and sustainability as well. Those are the customers we work with to try and fund what we are doing today. So that kind of frames why we're doing direct air capture. But what is it? And the cool thing about working with a team and a group of engineers, scientists, kind of scientifically minded people, let's have a look at a video.
The air is drawn into a collector with a fan, and CO2 is captured on the surface of a highly selective filter material that sits inside the collector. Next, once the filter material is full of CO2, the collector closes and is heated to around 100 degrees Celsius. Using the carb fix method, the captured CO2 is then mixed with water and pumped deep underground where it mineralizes and can be stored permanently for thousands of years.
So that's roughly the end of the good media looking slides. The rest of it's going to be some of my butchered attempt at media slides. This is a photo of our first ever commercial facility, and the two you see there, those are Jan and Christoph, the founders. They're Swiss. They invented the sorbent material that goes inside these machines that capture the CO2. And what you see there, and I want to show kind of a bit of a closer up picture, are 4 of what we call our collector containers. The containers have fans on them. Those fans are sucking just air from the atmosphere straight through, so it doesn't need to be located near any heavy emitter. It can be located in the nature and the wilderness of Iceland, where we have access to cheap renewable energy, as well as really good carbon dioxide storage. Those machines are sucking the air through, CO2 is getting captured on those filters, and then through the network of pipes, it gets stored underground. And now peeling that back one layer, this is an aerial view of our second facility called Mammoth. Each of those collectors, you can just see them at the front in that kind of like V-shaped formation. Each of those is a tower or a set of 3 stacked on top of each other. They're actually the same form factor as a container. You actually just use a standard reach stacker to handle them, and that was an important design premise that we had, was to be able to ship and handle and use regular industrial equipment. Let's use a collector container form factor. And to pause and to maybe highlight one of the fascinating challenges that I have to deal with here is what you see there on the left-hand side. In the left hand, what we call the process hall, which the collector containers are in front of, are pieces of equipment, brands that you're all very familiar with. Atlas Copco compressors, Alfa Laval heat exchangers, motors, pumps, pipes, vessels, bog standard maintenance that you can pull off a bookshelf. The interesting thing is our maintenance hall. These collector containers we've designed in-house, manufactured with a contract manufacturer, and we also commission, operate, and maintain them. And we own that technology. So one of the unique things here is not only are we the OEM of the technology, we're also the owner-operator. So when my collector container breaks, there's no one I can pick up the phone to call. I can only call myself. So I'm waking myself up in the middle of the night going, oh crap, well, I'm not producing. I better call my right hand to fix it. So there's no one else to turn to, and that is a really fun and interesting challenge that we're dealing with. So now that you've got an understanding of what is direct air capture, what are the machines, what are the bits and pieces that go into one of these, let me share with you kind of 3 lessons that I've taken from not just my time at Climeworks, but through my career as well at Tesla Solar and Exxon, about what I have seen as some of the key things that have made maintenance and reliability possible. And I'd like to start at the beginning of that cycle, so designing it right. Secondly, we'll look at the team that does the maintenance. And then lastly, a theme I heard quite a bit is you still have to sell maintenance not as a cost center, but as a value adder to the executive team, to the C-suite. It doesn't matter that I'm sitting around the table with these guys, I still have to sell it. And it's a really interesting challenge. The interesting thing for me is, and if Krista's opening was actually really interesting, what you'll find, the fundamentals haven't changed in the last 65 years. The same basics that you applied to aqueducts are exactly the same things that you're probably going to hear today. And the first one, making sure that we do genuinely embed maintenance and reliability early in any product design lifecycle or any project or plant design lifecycle as well. And I'll highlight 3 times where this has happened in my career and 1 time where it just didn't work at all. So quite traditionally, if you look at a waterfall or any Gantt chart, you've got this design, build, operate, maintain, the start of production, somewhere at the end of mechanical completion and commissioning. The way that I've always thought about this is you've got to bring operation and maintenance way up front in that design stage. Because if you don't design it right from the beginning, you haven't got a hope in hell of getting it right at the end. Oh, you do, it's just a lot of work, and maybe for us that's why it's good you've got bad designers, that keeps all of us in a job, right? But our jobs would be so much easier if the designs were right at the beginning. So one of the things that we've done at Climeworks is I've said, hey, I need to have a maintenance technician or reliability engineer sitting in the design team. And in our product design gate reviews, there is always a dedicated maintainability review. And that actually helped, and if you look at this, this is our next generation design on the left. This cube, it's got 4 of these containers stacked on each side and each face of the cube, and this door that moves up and down. It was actually pretty funny. I was down at the Baker Hughes booth before and forgot that Baker Hughes had acquired ARMS, and ARMS Reliability had actually done the reliability study for us on one of these pieces of kit and identified the door as one of the biggest headaches. Indeed, it is one of my biggest headaches. So the design team was like, hey, look, the way you're going to maintain that when it breaks, ideally it's highly reliable and it doesn't break, but look, you're going to have to change the wear parts on it, is you're going to lower it all the way to the floor, detach it from the rails, wheel it out, wheel in a new one, and then put that one up again and work on the other one in a maintenance bay somewhere. And we're like, guys, no, like that's just not going to work for us. The amount of downtime that's going to cost us and the lost efficiency, it doesn't solve. So what we ended up doing, and we did support that with some numbers around downtime, payback periods, and there were some other things that happened where we then ended up kind of shifting our architecture of the actual product during this concept design phase to now just having kind of 2 rows of vertically stacked containers and then a door that moves horizontally. And the elegance of this solution, and what you'll see there in kind of that empty space, is we've just hidden the steel there, is that now we've got a maintenance bay for that door. So all we have to do is move that door into a park position, and the guys have a dedicated maintenance area to work on that door as quickly as possible, perform the routine maintenance, and put it back into place. So without that voice of the maintenance technician or the reliability engineer early in design, I'd be dealing with the headaches of trying to fiddle around with this door every day, and that's a lot of work. That was an example from product design. I'll bring you one from Tesla and deploying new manufacturing lines or new plants around the world. So after having spent my stint as the maintenance manager in California, I went through and did the manufacturing line designs for the other facilities around the world. And China was the first facility. And I remember back in, it was December 2018, I'd gone over, done all my vendor scouting to figure out who would be the right person or the right partner to supply our manufacturing line equipment. And I was sitting in the office there, and the recruiting team was like, hey, we've got your we've got interviews next week on Tuesday for your ops manager and your maintenance manager. I'm like, when are you flying out? I'm like, well, I was planning to fly out on Thursday. And they're like, next Tuesday, that's Christmas Day. And they're like, yeah, we're going to get KFC for everyone. It's going to be a great day. So the moral of that story is the guys I actually interviewed, the ops manager and the maintenance manager, and this is before I'd even cut a purchase order for any equipment, they were the ones I hired and brought on in January. And they were actually with me reviewing my funding request to Elon for the manufacturing line itself. They were involved in the decision-making process of which vendor did we choose, who do we work with, and every single design decision along the way. We wouldn't have been able to get that line designed, built, and commissioned in 9 months without that really tight-knit integration between the operations and maintenance team as well as the manufacturing engineering team. And I didn't give my manufacturing engineers a choice. You guys are living with me in China. I was born in Hong Kong, so lucky for Tesla, they didn't have to worry about my visa. They're just like, oh, great, you can just stay there. So I ended up staying there in a hotel for 9 months. The rest of my team, they hated me by the end of it. I actually caught up with one of my friends here in London, and she's like, Doug, I effing hated you at the end of that. But when I look back at my experience, those were the best 9 months of her life. So when you go through something like that, working so closely with the operations and maintenance team, it really builds and develops you as a project engineer or a manufacturing engineer. The cool thing about that was at the end of 2019, crap, I had to go design build Germany. I hadn't met all my OEE targets yet. I'd hit my cycle times, my availability was nowhere near where it should be, and my quality, I was still scrapping cars, which is not great. But Kevin, Martin were like, Doug, we've got this. You go sort out China. We know you haven't hit your performance guarantees, but you haven't let us hanging. You haven't left us hanging. And they were willing to take ownership of that line way before any normal operations team would ever say yes to something like that. So that for me is a huge success story of what you can do when you bring in your end team, your maintenance crew, who are essentially our commissioning team at the end, early in your manufacturing, engineering, and project process. Now, COVID threw a span. I was like, I'm just going to clone this and do Germany the same way. And then COVID just kind of broke all of that. All of our travel was cut. It was really hard even just to hire the people, work face-to-face, be together to make those decisions. And what ended up happening, it wasn't a disaster, but we were still left with that kind of like that us and them mentality between the operations and maintenance team as well as the manufacturing and engineering team. We did work through it at the end. We did get there, but it took a bit more blood, sweat, and tears to do that. Now, lastly, very, very basic one, and I'm sure you all do it. Lessons from the field, breakdowns, make sure you get those back into your design specs. Now, the first question you might want to ask, and that's actually the first question I had to ask Climeworks, was, do you even have a set of specs that we're iterating on? Because if you don't have that, you're hard out of luck. And actually, when I did the first paint shop at Tesla, our specs were lousy. They were 20 pages long. But we started with something, and you have to start with something so that you can then build upon it. I mean, it's not ever going to be a 20,000 long global practice like Exxon has, but you've got to make sure that the lessons that you learn from the field don't just end up in a fancy PowerPoint slide somewhere, but they actually end up in something that the engineers and the designers do use in their day-to-day work. So that kind of brings me to the end of the design phase. Then what about the operate maintain phase? And there's no rocket science here. The right organizational structure gets you good results. So what I'd like to show you here, and maybe a second exercise here as we bring the lights up, and the last interactive exercise I'd like you guys to do with each other. What we've got here for, call it kind of roles that we see in a direct air capture plant. We've got Ibrahim, our process operator, monitoring the DCS. He had a bit more hair when he joined us. He's going all right. You've got your standard industrial kit, flow meters, compressors in the bottom left. You've got our workshop where we're doing the repairs, the maintenance, the overhauls on our in-house bespoke collector containers, the technology that we designed and built. And then we've got the field. We've got the team that's doing the running repairs or the running maintenance on the machines that are operating. Now, I'll give you guys probably just a minute. Turn to the person next to you. How would you maybe draw the analogies to your own teams? How are you set up? You've got process operators, regular plant equipment maintenance, you've got a workshop, and then you've got the field. So just take a minute, turn to the people next to you, and just discuss how does that setup reflected in your organizations. All right, that's taken us to the end of the minute. So, spending time as a vendor, going to many sites, having also spent the time in Tesla, seeing different manufacturing lines and their setup, and then the time at Exxon as well, I was like, look, I don't really mind an operator-maintainer setup. Let's have a pool of operator-maintainers working under our production manager, looking after the process panel, doing permits, doing the maintenance activities on your run-of-the-mill equipment, and then also doing some of the field activities. And then we'll bring in a team of contractors to help work in the workshop. And a few of us in the leadership team decided, look, it's probably the most efficient way because, look, it's really cool that we have all of this under our own umbrella. Like, if I'm going to wake myself up, like I said, it's going to be the left hand waking up the right hand. Now, that is, I would say, one of the mistakes that I made when I set up the organization in this plant. People were able to, get a kind of a very superficial understanding of all of these problems, but at the end, they weren't able to solve all of them, and they weren't able to feel the ownership over trying to run the plant efficiently, fix equipment that they actually knew how to do. Then they suddenly had to go work in the field on a piece of technology that essentially got shipped over from our technology team. Cody, my maintenance supervisor, hated me because he had to keep borrowing operator maintainers to try and do his plant maintenance. So what we ended up doing was then changing the organizational structure. We said, hey, we're going to have a dedicated team of process operators. You guys are going to run the panel, issue permits, do our lockout tagouts. Then let's give Cody a couple of maintenance technicians who have spent time in industry before, who know how to calibrate a transmitter, who know what needs to be done to repair a compressor. And then those that were a bit of kind of like more workshop and handyman, we put them looking after both B and D. So they're in the workshop as well as in the field. And what this has really led to is two things. So we really improved the empowerment of each of those people for the tasks that they're doing. They no longer have to today split their attention between, hey, am I writing a permit, and then trying to go into the field and repair a door that's failing. That's allowed us some operating efficiencies in terms of a reduction of a number of people. And in general, it's made the plant a much more efficient place to run. And the only way I was able to kind of come to that conclusion was through winter, we were struggling to ramp up, and I spent a lot of nights and days just sitting there with the operators. I set up my desk right next to them and just listened to them. Tried to understand what their pains were. And this kept coming up. They're like, hey, I want to work on that, but I'm stuck with this. I want to go help out in the workshop and see what they're doing, but I'm being asked to go work on the compressor. What I could see is that their attention was split way too many ways to be able to be effective. And now that they have a body of work that they can own, that they can feel proud of, when I was back there again 2 weeks ago, you could just see how much happier they all were. But one of the cool things from, let's call it this mistake in the organizational structure I made, was they all know what each other does. So when the guy fixing the compressor is like, oh shit, I'm going to need to go get a permit first, like it's just second nature. He knows what the rest of the plant will do, and he knows how to interact with each other. So there are many organizational structures you can adopt. Work with your other teams. Work with other facilities or peers in the same industry and figure out what's worked and what hasn't worked for them. And look, if you make a mistake, which is one of the things that I really like about working in startups or scale-ups, is you make a mistake, you fail fast, you try again. So lastly, how do we sell all of this? And if you give a CFO a headcount reduction, they're not even going to ask, right? It's like, hey, you were meant to give me a headcount reduction. Eventually I want to see zero, which just doesn't make any sense. But when they see your operating plant, when they see maintenance, when they see flogged out bearings, when they see rusty drives, when they see scaled up tube bundles, it's just cost, right? All they see is cost. How do we change that? Now, what I found is you've got to just speak the language and figure out what that right language is for the CFO that you have. I really enjoyed Drew's presentation this morning. It was a really strong link of the KPIs through to kind of the really detailed balance sheet that a super savvy CFO, that's what they love to see. Fortunately, my CFO is a bit simpler. He only thinks about two things. One, cost per unit. So cost per ton of net carbon dioxide removed, because that's our product at the end. It could be cost per candy bar, cost per barrel of oil, cost per megawatt hour. At the end, your costs, if you can drive your costs down, he's got his sales price, so he knows his profit margins are going to go up. And when he sees that I can increase production, so when he sees the denominator of this equation going up, he knows, okay, this is going to benefit my bottom line at the end of the day. Very simple graph. The green money that you spend boosts up your availability, you end up with higher OEE, and you end up with more production. And that actually speaks to him. So every quarter when he has to do his investor report, he asks me for this OEE waterfall and says, hey, what happened? What did you do to bring up production and drive down cost? And generally, performance and recovery are pretty standard, or performance and quality, and it's just the fluctuations in availability. And he understands that the money I'm spending is directly correlated then to driving up availability and improving the bottom line of the company. The second one that speaks to him is payback periods. This applies both on the left with your annual maintenance costs, which you need to spend to achieve production targets. I mean, you see a pile of encoders like that, first thing everyone thinks of, bad actors, right? So let's spend some money, get rid of these bad actors. At the end, improve availability, drive up production, reduce cost per unit. And then the last one, kind of that example I gave you at the beginning about the door park position. We were able to then figure out the payback period of adding that 9% of extra steel, which had an extra 0.5% CapEx impact on the product. But the overall availability and uptime we got and the throughput as a result meant that that design paid for itself at the end. So moral of the story here, make maintenance relatable to your C-suite. Speak their language, figure out what it is. Candy bars, payback periods, cost per unit. If they speak in WACs and IRRs, great, speak to them in WACs and IRRs. It just means you have to do a bit more work. And then the second one, bring them out to the field. That just helps them relate to what you're doing day to day. I mean, it's interesting, and just sharing a final story there working with Elon, it was actually really easy to work with him because at the end, he's an engineer. Like when he came in after I'd been black for 24 hours because I'd blown all the electrical circuits in the paint shop, he knew I'd been there all night to fix it. And he's like, Doug, what did you do to fix it? I'm like, it was this stupid strand of copper that was shorting out two of the rails on our carrier system. And he's like, I want to see it. I'm like, okay. So we jumped up in a scissor lift and just got up there. So unfortunately, not all executives are that hands-on. If you do have one that hands-on, that's great. But bring them in, make them feel like they're part of what you're doing. So thank you. I'm thrilled to be part of this mainstream community. Like I said, I've drawn so much energy from meeting you guys, from the conversations, from the debates, the panels. It's such an honor to be part of this group. And I'd love to have a drink with you guys this evening and connect with you further on down the stream. Thanks, guys.
Thanks, Doug. Well done, mate. It was terrific. All right, folks. How good? How smart is he? Amazing. Great stories. What an amazing plant. What amazing work you guys do. And what amazing work you do, Doug. And fully got that. Even